Hello and welcome to the third section of our course. In the videos that follow, we'll learn how to implement authentication for our API on both the server and the client with a focus on security practices. We'll start by establishing an authentication scheme where the user submits credentials and receives a token that can be added to the header in subsequent requests to authenticate their identity. We'll then expand our scheme to allow for cookie-based authentication, making sure to prevent cross-site forgery protection. Next, we'll move to the client and see how to manage and submit form state in Redux, and finally we'll learn how we can persist the logged in user so that the client knows that the user's logged in without having to ask the server. For our first video, we'll be looking at token-based authentication. In our last videos, we created some database tables and seeded an admin user. Now we need a way for that user to log into the app. We'll begin by defining an endpoint where we can submit a username and a password and receive an encrypted authentication token in the response. We'll then create a protected API endpoint that will raise an error if it doesn't detect a valid token. Along the way, we'll be using a tool called Insomnia to test our API by making web requests and inspecting the responses. For starters, we'll need a couple new dependencies. We'll use body parser to give us easy access to the request body, and JSON web token to generate our auth tokens. Since we're doing a lot of back-end work, I also want to install nodemon to automatically restart my server when I make a code change. Now I'll tweak my server script so that it runs using nodemon. And now let's get the server running. So with that out of the way, let's create our authentication endpoint. I'll start by importing the packages I just installed, as well as the bcrypt package so that I can hash passwords and compare them with the database value. Next, I'll tell my Express app to use my body parser middleware, which will parse the request body into an object for easy access. So now what we need is an endpoint that takes a username and a password and tries to match it to a user in the database. First, I'll define a function to see if the username exists. It queries the users table and returns the user's attributes if it's found, or null if it doesn't exist. Now to create the endpoint. First, I'll get an instance of the Express router and mount it at /API. The authentication request will be an HTTP post to the API/session endpoint. It will start by destructuring the username and password from the request body and feeding the username into the lookup function. If we didn't find the user, or if we did but the passwords don't match, we'll return a generic error to the user. If the username and password are both good, we can create our auth token. We'll create ours by encrypting our user data minus the password, and we'll attach the encrypted token as well as the user data to the response. The token needs to be signed with a secret key for protection. For this example, we are hard-coding the key. In reality, you'd want to store this key as an environment variable on your server's machine. Our API endpoint is now defined, so let's open up Insomnia and issue some test requests. If you're not familiar with Insomnia or similar tools like Postman, I encourage you to spend some time getting acquainted. I currently have an environment set up with a base URL variable pointing to localhost 9999/API. On the left, you can see that I have a session folder that contains a couple of endpoints that we'll be using today. The authenticate request does a post to our API/session URL, which performs our auth logic. I can specify a JSON request body, so let's test our error scenarios first. I want to see what happens when there's no request body at all. On the right, we see the response. We got the invalid credentials message, which is what we'd hoped for. Let's try a good username and a bad password. And here again we get the same error message. So now let's submit some good credentials. And now I get a 200 response with my token and my user data as I expected. So now that we have an authentication token, the next step is to define an authenticated route that requires a valid auth token. I'm going to start by defining another middleware function called decode. This function looks for a token in a header labeled auth token. If no token is present, we can return an error immediately. If we do have a token, we need to verify its authenticity. We use the verify function from JSON Web Token, passing in the token, our secret key, and a callback to be performed when verification is complete. If the first argument has a value, it means that the token failed verification, so we return an error. Otherwise, the second argument will contain the decoded token, which is actually just our user data. So we can attach that data to our request object and call the next function. At this point, any middleware or endpoints that run after this code will have access to the current user. So now let's define a protected endpoint using this middleware. If a user makes a GET request to API/session, our endpoint will use the decode middleware function. Because of this, our endpoint only executes if our middleware successfully verified the auth token. Now we'll just write the current user to the response. Let's give it a test. If I submit my request with no auth token, I should get an error. On the right-hand side, notice I get the no token provided message. So let's grab the token from our last authenticate request and attach it. Now I get a 200 response with the user info, which means I verified my token successfully. Just for fun, let's change the auth token header to something that should fail. And we get the 403 saying it can't authenticate, so everything seems to be working as expected. That's all the time we have for this lesson. Today we saw how to use JSON Web Tokens to authenticate our API.